Ready? Okay. Thank you, everyone, for coming here, and I made it as well. Great to be here in New Zealand. This is my first TechEd New Zealand. It's my second time coming out to New Zealand. The last time I was here was for a conference called CodeMania a few months back, where I had the pleasurable experience of jumping off the Sky Tower. Woohoo! So I work on the Windows Azure team, and I've been heavily involved with our Node.js story. How many developers here have used Node.js or are familiar with it? Okay, small number. How many are familiar with Windows Azure? Okay. Well, it's not an intro to either one of those, but it will be talking about developing Node applications in Windows Azure. So these are the kind of things we're going to cover. We're going to talk about how to deploy a Node app to Windows Azure, diagnostics and debugging, configuration, cloud-based storage, real-time messaging. So we've got a lot of stuff that we have to cover. So let's start talking about how to deploy Node apps to Windows Azure. Now, we've worked really hard to have a lightning deploy experience. So one of the things we have is, let's put that away. Let's close that.
That's not a good view, eh?
Say that again?
That's not a good view, you've got an exception.
Ah, okay. So what I'm going to do is we actually have a command line tool, cross-platform command line tool, which actually works in Windows and Mac, and it's called Azure CLI, the Azure command line tool. Anyone here familiar with Azure CLI? Okay, well, you're going to see it right now. So when you install Node.js on your machine, you get this thing called NPM, which is the Node Package Manager. And in NPM, you have modules which are libraries that you'll use within your application, but you can also have command line tools. And so we've published a command line tool there called Azure CLI. And so to get it, you just do npm install Azure CLI-G. Is the font big enough for everyone? Okay. So this is going to go out to the Azure registry, and it's going to get for me the Azure command line tools. And once those tools are installed, you'll actually have an Azure command that you can run from your favorite shell. I'm using PowerShell. You could use Git Bash. You could use whatever you want. So then you run Azure. I love the way that color changes from blue. Let's see. Okay. So this is Azure, and we're bringing back ANSI art. ANSI art is cool again, as you can see with our logo there. And Azure allows you to manage pretty much most of the things that you have in Windows Azure, all your Azure assets. So I can manage storage accounts, I can manage SQL instances, I can create virtual machines. Recently, we added support for HD Insight, which is our Hadoop story. And we also have support for websites, which is what we're going to spend most of our time on right now. Now, when I first get this command line tool installed, what I have to do is import this published settings file. And the published settings file is a file that you can download from the Windows Azure portal. So we have this Azure account download, which will take you to the portal to log in, and you can either create a new Azure account or you can log into your existing account, and then you can download your published settings file, and then you can import it. And once you import that, you then have the ability to manage your account. So you can think about the importing of that file as a way of passing in credentials so that you're giving the permission to the command line tool to be able to work with Azure. So I've done that already. So now I can do this thing called Azure Site List. And what that will do is show me my websites. So the way that we allow really fast deployment in Windows Azure is through websites. And we support Node for websites. So I'm going to show you what the experience would be to create a very basic Express application and deploy that to Windows Azure. So I will just go into my and I'm just going to make an app called GB Express. So Express is also a module that you can get from NPM. and you can install it globally, and it will give you a command line tool that you can use for generating a starter Express app. I'm sure Ian will go into this more in his Node talk. So I type Express, and hey, it's created for me a very basic Express application. Now, one of the things you'll notice that it's created as well is it's created a package.json. As I said, Node has packages. So when you create a Node application, you need to specify what packages you have. And the package.json file is a way of doing that. And then you can run npm, the Node installer, by doing npm install, and it will install any of the modules that are associated. So now that I've done that, I'm able to run this app. But I don't really want to deploy all those modules to the cloud because I don't want to put those in my Git repo. I'd rather I could just deploy my code. And we allow you to do that in Windows Azure, so I'll show you that now. So now I want to create my GB Express website. So I can say Azure site create GB Express. And if I add this parameter -- git, what it's going to do is create for me a Git endpoint that I can use to push my Node application to Windows Azure, and it will instantly deploy. We also allow you to do GitHub. And if you do GitHub, what we'll do is if you have a GitHub repo, it could be a private repo where you've deployed your application, you can wire up that GitHub repo so that it will do a post-event hook, which means that anytime you push to GitHub, automatically that will also get deployed to Azure. So we offer both models. The one that most commonly people use is Git. So I'm going to go do that now. It's going to prompt me for locations because Windows Azure is distributed throughout the world. You actually can pass the location as a parameter, but I just wanted to show you that it will give us the list. OK, so now I have the option to choose where I want to deploy it. I'm going to deploy it to East Asia because that's close to us. That's in Singapore. And it's going to create my website. Going to take a few seconds. There we go. It created the website. And then what it does, which is really nice, is because I specified -- git, it will automatically call git init to create a local repo, and it will add the remote for me so that I'm ready to go just going and pushing this to Azure. So the next thing I do is do git add to add my files. I'm going to go commit, and I'm going to push. Now it's going to prompt me for my password. And then it's going to be deployed. So what you can see that it's doing now is it's actually running npm on the server. So I don't have to push the modules. I can just push my package.json. We'll automatically understand that, and then we will go and run npm for you. When that finishes, my site should be ready to go. Just going to take a few seconds while it's downloading all the modules. There you go. Deployment is completed. Oh, please don't do this now. Let's leave that alone. Let's just ignore it and hope it's not going to restart. OK, so now if I go to gbexpress.azurewebsites.net, I see welcome to Express. So that was how fast. Once I'm ready to go, I can just simply create my website, enable Git, Git push. Now that Git is already set up, I can simply make modifications to the files, and it will instantly update it. So I can go here into my app.js, and actually what I'll do is I'll just go to the view file. So if you're not familiar with Express, you can kind of think of it like an MVC type. It's not MVC. It's not even a MVC pattern, but it's a web framework. It's actually inspired by Sinatra. If you've heard of Ruby, Sinatra is a very popular web framework, which Express was built based on. So now I'm going to say welcome to blah again, and I'm going to push again. So I will have a commit. I'll need to commit locally. And now I'm going to push again, Azure Master. This time it should go much faster because I'm only pushing that one file, and it doesn't need to run npm again. There we go. That's now live. I might have to restart. Let's see if I need to. Yeah. Okay, thanks. Welcome to Express again. So we can see that I made a change instantaneously. That change was live in Windows Azure by doing the git push. I didn't have to have the node modules install again. One other thing you might have noticed, if we look at the output we got here, is the fact that it says, hey, the Node.js application will run with the default Node.js version 0.10.5. So for a while, we had kind of an old set of versions out there. We've recently rolled out a newer version. We have several versions that we support. The way you can select your version is using your package.json. So it's a standard convention in the Node community that in package.json, which is that configuration file, you can put an engines block. And in that engines block, you can specify what Node version you want to use. And we will honor that. If you don't put a Node version, then it's going to default to the latest one. Now, in the past, and this was a recent enhancement that you're seeing, we could not allow, whenever you create a new site, to use a newer version, because we only had a single version of the runtime, and you could override it with package.json, but we had no way of capturing the default. We recently added now capturing the default Node version that you've deployed with, so that even if you haven't selected in package.json a particular version, we can upgrade to say that, hey, the next time you create a new site, you get the newest version of Node available, but it won't affect your existing sites. And the reason why we wanted to put that mechanism in place is so that your app doesn't magically break because suddenly it got upgraded to a new version. That would be pretty bad if your app was deployed, running in production, and suddenly we decided to say, hey, we upgraded you, and the modules that you had maybe weren't compatible, and it broke. So we now have this feature called version pinning, which is very powerful. So it means you just don't have to worry. You can still change your version, but we'll make sure that we capture the version that you deployed with, and it will never change unless you decide to change it. Yet we'll still be able to keep moving and upgrading to allow the newest version. So that covers the Git deployment model. Now, one of the things we also allow you to do is you can manage the deployments and you can do rollbacks. So let's say there was an error and I needed to roll back. So if I say Azure Site Deployment List, you'll actually see that I get a list of deployments. And you can see there that each time I've pushed, it's actually created a deployment for me. So let's say when I just pushed, there was a bug and I need to roll back. What I can do is I can take this commit ID here, copy it, and I can say Azure Site Deployment Redeploy, and I can give it that deployment ID. Oops, not that one. The commit ID. Let's try that again. So I will go here, paste that. There we go. So it's going to say, hey, do you want to redeploy this particular ID? I'm going to say yes. So it has now redeployed to the first commit. So if I go back to the code, I should see that it will go back to the original state. There we go. So that's useful in case any kind of bugs or something was, deployed. You can instantly roll back to the previous states. By the way, everything I'm showing you is accessible through the portal. So if you prefer, you can certainly log in to the Windows Azure portal by doing manage.windowsazure, by going to manage.windowsazure.com. And everything I'm showing you is available there in the GUI. But the CLI is nice because for power users, really. Like once you get going, you know how things work. You can do it really fast within the CLI. Any questions on what I showed just now? Okay. Now, this is a little shameless plug, but some people, what they want to do is they want to run whatever Node version they like. Like we have a limited set of versions right now. We are opening that up. So I created a Node module called Node Tuneup. And what Node Tune-Up does is it gives you a CLI that will allow you to set up a website so that you can easily update to whatever Node version or NPM version that you want. And the way it does that is it sets up your website so that when it deploys, it will actually go out to nodejs.org and download the particular Node version that you specified. So anything that is available in the Node library, you can get to it. And all you've got to do is create a website and then run TuneUp on top of it, and you'll be all set up to go. And it will even allow you to configure your Node version in the portal. So I'm not going to show that to you right now, but you can read exactly on how it works. If you go to my GitHub site, actually I think I moved it to the Windows Azure contrib site. Let's see if it's there. Yes, Azure Node Tune-Up. And you can read about how this works. So again, so that's going to give you the flexibility to go beyond just the versions that we have installed and choose whatever version that you want. So you guys might want to try that out. Any questions? Yes?
Yeah, what kind of Azure using?
This is, you mean, it's an Azure website. Are you not familiar with Azure websites? Okay. Well, just high level. So we have, in Windows Azure, we support multiple different deployment models. We have platform as a service, and we have infrastructure as a service. Infrastructure as a service are virtual machines. You just set up VMs and you go. We have cloud services, which has been around forever in Windows Azure, and that's where you create a package and you upload that package. We create a VM for you, and you can manage that VM. But the apps have to be designed in a stateless manner. They scale out infinitely, but you have to design them around that infrastructure. And then we recently rolled out last June a feature called Windows Azure Websites. And what Windows Azure Websites does is it lets you just deploy an app. You don't have access to the virtual machine. You can request what's called reserved, meaning you can pay to get a dedicated machine where things are running, but you still don't manage it. It's platform as a service. We manage it for you. So basically what that allows us to do is have a virtual machine that's up, and when you go to deploy, we don't have to create a new virtual machine. We're just creating a container, an isolated container within that machine, and that is where your app is running. So that is what this is. When I'm deploying this Node app, the machine's already up and running, and we're just able to run in a very isolated fashion. It's a container within that one of those virtual machines that are available, and that's why you can deploy very quickly. Does that make sense? Socket server will not work because, well, you could use WebSockets, but you can't open arbitrary ports. Windows Azure, everything is over port 80 for websites. If you want to do arbitrary ports, you need to use like IaaS for VM, or you need to do, if you're not doing HTTP and you want to just do like raw TCP/IP, you wouldn't do that from Windows Azure websites. You would do that from a cloud service, or you would do that from IaaS. That's why it's called websites. It's really built around port 80. Yes? Did you have a comment or question? Okay. So let's move on. So that is deployment, which I think you can agree is pretty quick. We're out very quickly, and we can do this both with websites from the command line or from the portal. So if you look at our site command, and all these commands you can just do help, and you'll get all the detail. So you'll see that we have an Azure Site Scale command. So with Azure Site Scale, so Windows Azure Websites, one of the things that's nice about them is they're designed in a way that inherently we can easily scale them out and run multiple instances. So from the command line, if I need to, I see that my load is increasing, I can do Azure Site Scale. I can set up my scale mode because by default, by the default sites are in kind of a free mode, but you can scale up to reserved. And then you can basically say, here's the instances that I want to scale to. Now, we don't have support yet for configuring auto-scaling, which is a feature that's now available in Windows Azure Websites from the CLI, but you can definitely do that from the portal, and it will be coming to the CLI as well. All right, so that covers deployment. Now, what about real-time diagnostics? So how do I know what's going on? What happens if my Node app fails due to an error or something like this? How do I get this kind of information? A very common problem is I've deployed an app and I haven't included a module that the app requires. So what happens is the app deploys and it just breaks. But I'd like to get some insight into what that is. So in Windows Azure, we have several mechanisms that allow you to inspect what is going on within your application, but those have to be enabled. So I'm going to show you that now, and we'll use our Express app as a sample of what could happen. So I'm going to go into the app.js here, and I'm going to just require a module that doesn't exist called foo. So I can see now that it's been modified. I will commit it, and I'm going to push. So if I go to now look at this, hold on, let's go back to, it should give me just a cryptic error. Yeah. But what I can do is when we create a website, or when you use our CLI to create a website, you get this file here called iasnode.yaml. And it has a couple of different things that you can enable. You can enable logging, you can enable debugging, and you can enable dev errors enabled. I'll leave off debugging for now. So I'm going to turn on logging, and I'm going to turn on dev errors enabled. So now I'm going to jump back here, and I'm going to commit that. Or enable logging, whatever. So now I can actually see the real error that happened within my app. I can see that the problem here is that the foo module was missing. And this is really useful because when you're doing cloud-based development, often you may think, you really get hit on the it works on my machine. Everything's set up nicely on my machine and it's running. What happens when I go to the cloud? When I go to the cloud, it's not working. How do I figure that out? You can enable this debugging. The reason we allow you to enable it and disable it is because you may not want to serve this information up to your customers who are looking at the website. So this way you get the control of using this, say, in a staging environment or during development. And then what I could do is go back and use our lovely redeploy command. So I can say Azure Site Deployment. Actually, I should have it in my cache here. Where is it? There we go. And this would be useful even if this was in staging. Like I made a mistake, staging is broken, let me move it back. I can do that instantly just with the Azure Site Deployment Redeploy command. So that's one thing that we enable you to do. But another is that Node apps are often writing to the console. Anytime an error happens, what will happen is the Node process will just dump that out to standard out or to standard error. But you also have logging APIs, like the people use console.log, which can just write out arbitrary information, or they may use Node modules like Winston, which is a very popular logger, and it just writes to the console unless you configure it otherwise. So one of the things we've added is the ability to real-time see that information that's going out. So that's different than what I just showed you, which is the dev errors page, which is nice for giving you contextual information about an error. So the way we do that is we use this Azure Site Log Tail command. Now, one of the things you also may not have noticed, I'm not having to type GB Express every time I do a command. So by convention, we actually know that this folder, based on the Git repo that's there, we know this is a website. So it's just easy. It's just one less thing that you have to do. You can specify if you want to. If you want to control a different website than the folder that you're in, or you just want to control a website and you have nothing locally on your machine, you can absolutely use these commands and specify the site. So I'm going to do Azure Site Log Tail, and you're going to see it's actually now going to connect to my site. So if I refresh the page now, I should get some output from Express. Now let's see. There you go. So that GET call is actually a log entry that the Express server is writing out. And I'm now streaming that down. So that's extremely useful. I'll show you another app that dumps quite a lot of data so you can see how you could really use this for something better than this. So I've got this chat app. And we're going to see what this does in a few minutes. But now I'm going to try to connect to this. So now I'm going to actually specify the name. So I'm going to say sbchat2. It can support WebSockets. So it does support WebSockets. Well, Windows Azure today actually is not supporting WebSockets in websites. That's coming very, very soon. This is using Socket.io. And Socket.io is a very popular Node module that supports the ability to fall back to different protocols. It will use Comet and long polling. It will use WebSockets if it's available. So what you can see here, we're going to get into what this is actually doing. Here I have a lot more data that's coming. And it's extremely verbose, and we'll see how you could even write your apps so that you can configure information so that you wouldn't show all this debugging information unless you wanted to. But I just wanted to give you an idea of how this is working. So if I go here now and type a message, whatever, my name has two N's, but you'll actually see that it received a message, and you can see right here, there's the message, Glenn. I spelt my own name wrong. Please don't tell that to anybody. So it's a very valuable feature that you can use. And you get it for free just by deploying your Windows Azure website. And we don't just support this for Node now. We support this for .NET. We support this for all the stacks. Node was the first one that we rolled this out for, but we support this for everything. So that is diagnostics. Let's talk about configuration. So a common pattern for Node applications and PHP apps is you're going to have apps, some type of configuration settings. In ASP.NET, we have web config. But in Node, there's no standard there. But the most common pattern is actually just to use environment variables. So what we allow you to do is actually configure those environment variables right from the command line. And there's a couple of places where this is really useful. So you might have connection string type information or secrets that you don't want to put in a file, especially if you're putting that thing on a public repo like GitHub. So you can actually put those as config settings. But another place it's really useful is for staging. So you want to have two websites, one that's public that everybody's hitting, which is production, another that's staging. It's the exact same code, but the only thing you want to do is change what data stores it points to, what service bus queues it points to, et cetera. And you can do all of this using the app settings feature of Windows Azure websites, which in .NET actually leverages web config and it propagates into the config settings. But for Node apps, it will propagate to the environment so that you can just access that right from within your Node app. So I'm going to show you an example of that. And feel free to ask any questions. So what we're going to do is we're going to go into this file here, and we'll just have a foo. And let me see. Yeah, we'll call this just foo. Actually, what I can do here is I can put actual code. So I'll just say process.env.foo. I like foo, so I'm sorry. OK, so what I've done here is I've modified the view so that it's going to access the environment variable foo, which does not exist yet. So I'll go and push that, and we should see it say undefined. Oh, I didn't remove the module foo. Okay, well, it's a good thing I had the error handling enabled. So I need to go remove this. Because when I rolled back, remember, it didn't affect my code locally. It just rolled back what was deployed instantly. So I still had that error there. So now I've gotten rid of that. Okay, so it doesn't give me anything because there's no foo yet. So what I'm going to do is add foo. So the way I can do that is I have this Azure Site config command. And so with config, I can manage all of my environment variables for my Node app. So if I say Azure Site config list, you'll actually see that there's a default variable that we populate, which is what version I deployed my app with, so that even if I hadn't specified it in package.json, this is what is used to preserve that version that I told you about. We call that version pinning. So now I can say Azure Site config add foo equals bar. And I can list it. It will show me that it's there now. And if I refresh, you can see it's there instantly. So I don't have to restart or anything like that. As soon as I set those variables, it's immediately going to be available. If I scaled out to 10 instances of my website, it will immediately propagate to all those instances. Okay, so this is actually really useful, again, like I said, for staging or for just general configuration information. You could couple this with the logging feature I was showing before. So what you could do is you could say, hey, in my app, when I do my logging, you can define different log levels. So you could use an environment variable for specifying the log level that you want to see the output as, and you could set that using this, the Azure Site config, because we do have the ability to override. And then what you could do is, within your code, rely on that environment variable to then decide what level of logging that you're doing. And then when you do Azure Site log tail, you're going to see at that level. So you could easily go and say, oh, I want to see more detail. Go and update that environment variable, set it to something that's more verbose. And then suddenly when you do log tail, you'll see much more detailed information. Make sense? So that's configuration. And again, it's also available through the portal. So let's talk about data storage. So you're deploying your app into the cloud. You need a way to be able to get to data very fast and provision different types of data stores. So in Windows Azure, we have a number of options. We have built-in storage mechanisms like table storage. Table storage is a very lightweight NoSQL store for storing JSON objects and querying them. It's not super sophisticated. It works really well. It can deal with really large sets of data that can be geolocated, and it works really well for data where you just need to retrieve according to a key, or you can segment your data by these partitions where you quickly can get to that partition. We also have blob storage, which is a document store. You can upload any kind of arbitrary document into the blob storage, and you can retrieve that. And then we have other options like Azure SQL Database, which will spin up a SQL instance for you. We now have MongoDB as well. How many people here knew that we had MongoDB in Azure? So we now have Mongo in the store. I'm going to show that to you. And we have this really cool thing, which I'm just going to jump over to, called VM Depot. I'm guessing you guys have not heard of it. But what VM Depot is, now that we support Linux virtual machines in Windows Azure and we give you the ability to upload your own images, VM Depot is a library of hundreds of different images. So you can find things like Cassandra and Redis and other kinds of servers that you can easily set up as well for usage within your application. So you can deploy a Redis instance really fast, and it gives you the command for doing it. so that you can do it right from the CLI. Let's see if this is working today. Okay, let's see here. Go to main. There you go. So here's a Redis server image. And if I click on this deployment script and say, I agree, I can choose my region like Southeast Asia. And it will give me, this is using our CLI, it will give you the CLI command that you can just copy in, fill out the template, and a few minutes later you'll have your own dedicated Redis instance up and running. But our Node SDK allows you to access a bunch of the core built-in capabilities. So we have a Node SQL driver that will allow you to talk to SQL Server right from within your Node apps. And we have an Azure SDK, which allows you to talk to table storage and blob storage, etc. So I'm going to show you a demo of that. And then we'll take a look at what the code looks like for using the Azure SDK. So this is an app that I've deployed to Windows Azure. It's a Node application for working with blob storage. So it's basically a blob uploader. Allows you to upload documents, will get persisted into blob storage, and it can list and retrieve those. So I'm going to upload one. I didn't write the UI, but yeah, the UI needs work. This app, yes. If you go to our Azure, I'll show you where the Windows Azure repo is for the Azure SDK. You can find the sample for this blob uploader, yes. Okay, so I've gone ahead and I've uploaded this image, and now I could go and download it. So you can see that it's actually working. And this is something that might look familiar to some of you. This is me as I was getting ready to jump off the Sky Tower, terrified actually, but trying to hold a smile, when I was here about 5 months ago. Yes, I did jump. I didn't turn back. And I have a video to prove it. Which is right here. The best part is, wait, let's see. There, wait, hold on. There you go. Slight tangent. Nothing node there, but we could probably think of a node. All right. So how did that work? So the sample, which is available on our GitHub repo, and let me show you where that is. You go to github.com. This is all, Microsoft's been doing a lot of open source these days. So that Azure CLI is open source, and our Azure SDK for Node is also open source. So you can go to Azure SDK for Node on GitHub, and you'll see all the source for our Windows Azure SDK. And if you browse, we have examples. And under examples, you'll see that there is a blob uploader. And that is the exact sample that I'm showing right now, so you can get it yourself. So how does the blob uploader work? So we're requiring the Azure module. You don't need this kind of code here. We put this code here so that if you clone the repo, it will automatically just use the Azure module that you're in, rather than requiring it to pull down Azure again. But anyway, all you would do in your app is this, Azure require Azure. After installing the Azure module, which we do with NPM, you can see this is an Express app, so you can easily use the Azure module with anything. And then where it gets interesting is we have this blob client. So off of the Azure module, I can call this create blob service. Now, this would have been a fine place where I should be using app settings. No, the one on GitHub doesn't have credentials hard-coded, but for simplicity, I just hard-coded it. So I give it the name of a storage account that I've already created in Windows Azure, and I give it the storage account key. And then I tell it the container name, because the way that our blob storage works, but within the storage account, you can have 1 to n containers, and within those containers, you can then put individual blobs. You can think of it almost like folders. So once I have that, then I have methods like this, like list blobs. So this is Node, so everything's going to be async and get a callback. That's the standard pattern in Node. So you can see here that I'm doing blob client.listBlobs. I'm passing it the container name, and I'm giving it a callback that accepts an error and the blobs collection. Because we're using the standard Node pattern, you can use modules like async if you want to, which will help, which makes async calls easier, but I just didn't want to do that here. And then what I'm doing is I'm just grabbing the JSON blobs collection that got returned to me, and I'm rendering that out. And if we look into the view itself, there's many different view engines for Express. You can see that this one is using EJS. I prefer Jade, which is a tighter syntax that doesn't use any tags. But you can see here, this looks very similar to kind of ASP or ASP.NET. You can see here, not using Razor, but you can see here that I'm accessing the server blobs collection and I'm pulling the properties out. And it's just a friendly JSON object, so it's what you'd expect. Did somebody have a question? Okay. So with this API that we offer you, you can do everything with blobs. You can create them, you can upload them, you can retrieve properties like here. So once I select to download, this is the route that will get hit within Express when I select to download. You can see here that I'm calling get blob to stream, so I can then stream that back right to the client so that it will do the download. So we offer a nice set of APIs for doing that for blob. So that's blob storage. Now we also have table storage, as I mentioned. I'm not going to show that now, but what I want to show is MongoDB. So I talked about how, hey, we now have the ability to, using the Azure Store, you can create MongoDB instances. So if I go to manage.windowsazure.com and I log in, eventually it will get me to, okay, so I'm just going to say my account. Sorry, I'm not sharing my password. So if you've never seen Windows Azure, oh, nice. Let's try again in a few minutes. Let's try that. Well, no, I know why it's doing this. Let me do something else. Let me try this and do in private browsing, new incognito window. Let's try it now. My machine is domain joined, so it tries to log me in using my Microsoft account, my actual corp credentials, which can be a problem. So let's see if this works. Okay, we're getting in. So the Azure portal is an HTML5 portal, and you'll see here that in the store, which is down below, and it's a really nice experience. You can even use it from iPad or Surface or any device because it's just HTML5. So you can see I have add-ons, and I have a Mongo Lab instance, which is a MongoDB instance. So what I've done is I've previously deployed a website called GBMongo. And what this is a Node Express application that is talking to that MongoDB instance. And it's not doing anything, it's not using anything special. Okay, so here we go. So I've already presented in Oz, so I can update that. So this is platform as a service in the sense that I didn't have to set up a VM running MongoDB. This is MongoDB as a service. I just created an account. I can get a free starter account, and I can scale up as I need to. Now, I also mentioned how you could use Redis. So I actually have a Redis instance here running in Windows Azure, and I did it using that script that you saw. So you can see this gblock Redis SEA. I'm just going to switch over. I actually am on a Mac. There's the dirty little secret. So there's a Redis CLI. And what is the syntax again? -H, yeah. So if I say gblock Redis SEA, I think that is what it is, gblock Redis SEA, which is Southeast Asia, .websites.net. HTTPS, I think is why. HTTPS, gblock. What am I doing wrong? Gblock. Ah, thank you very much. You guys are awesome. Give them a prize. I don't have any prizes, but if you follow up with me, I'll get you a prize. All right, it is running because I have a Node app that talks to it. I'm doing something wrong here. Redis CLI, HTTP, gblock Redis SEA. gblock Redis SEA .cloudapp.net. Yeah, it should work. Okay. Well, I have a Redis instance running, and I use that mechanism to do it. And if you come to my mobile services talk, I'll actually show an app that is using Node to talk to Redis. Okay, so we are running out of time. So a common pattern with Node is to build real-time apps, like the chat app that I was showing you. And there's a great module in Node called Socket.io. But what happens if you want to be able to scale out to multiple data centers? So we've actually built a module called Socket.io-Service Bus. And what Socket.io-Service Bus allows you to do, and that's why you saw those messages coming, that was a Socket.io chat app, but it's actually using Service Bus as a backplane. So I can actually have clients running in multiple places that can talk to that same data. Now, I had 2 instances running in 2 different data centers, and one of them broke right before this talk. So I'm going to show you one of them, which we were using before. So if I go to SB Chat 2, there was an SB Chat 1, but it's broken now, so don't bother going there. You can join in this one if you want to. So if we look at that tail, what you saw before, Azure Site Log tail, and if some of you enter messages, you'll see those messages come across. So this is really cool because it now allows you to take your real-time apps and scale them out and really leverage the benefits of the cloud. It's useful even if you're in the same data center and you're just scaling out across instances. But it also has other things like scaling across data centers, including on-prem to the cloud. So you could actually have a server running locally on-prem, and you could have servers in the cloud, and they could basically use this Socket.io Service Bus bridge to communicate. Now, to configure it, what you have to do is give it a little bit of information. So if I do Azure Site config list SB Chat 2, you'll see that I actually used the configuration feature to pass in these 3 parameters. So I need to create a service bus topic. In this case, I'm using chat. I think we will create it for you, actually, if it doesn't exist. I need to give it a presence URL, which is the URL of my website. Because what it will do is you'll actually see when you run the different instances across the different data centers that it's actually syncing which users are connected. You can actually see the list of users. And then here is my connection information for specifying the service bus connection. It's the service bus connection string that it will use for storing the service bus messages. And just to show you quickly what that looks like in code, And then I have one more demo, and we have 3 minutes. I think I'm just going to make it. So here's my app.js, and you can see that I'm requiring socket.io, and I'm requiring socket.io-service bus here, which I installed from npm. And what's nice, the way we've done it, so socket.io itself actually has a store abstraction. And so it was designed with the idea that you can put different backplanes on it. You can use Redis, for example. So what we did, and we worked with Guillermo Roach, the author of socket.io, is we created the socket.io store, SB store. And all you've got to do is set the store on your socket.io object, which you can see here, and new up this SB store object, and pass it the topic, the connection string, and a logger. So you can even create your own logger if you want to. And that's all you've got to do. And you can basically use any socket.io app, and it will just work and scale out automatically because of the fact that you've used this store under the hood, which I think is pretty awesome. So the very last thing I want to show you, and we're just going to have 2 seconds to do it, is about living on the edge. So what do I mean by that? Living on the edge in this case means calling .NET code from within your Node apps. We have a module called Edge that Tomasz Janczuk, and he's worked on a lot of the Node stuff with me on Windows Azure, wrote, that allows you to bridge to .NET code from Node. Now, you use this for very specific things. The idea is maybe you want to use a library that's not available, or maybe you want to access things like the registry or other aspects of like the Windows OS that there's no Node module available for. Both of them are interesting, and a third might be you have legacy .NET code that has some logic that you'd like to use within your Node app. And a fourth is WCF. So it turns out that the Node community is not very interested in SOAP services, but there comes a time when you might have to call them. There are a lot of them that are out there, and it just so happens that .NET has really good baked-in support for WSDL and creating proxies, etc. So I'm going to show you an example of that. And that will be my last demo, and then we will be done. So I have a previously deployed website, and it is called GB Edge. So I'm just going to run that, and then I'm going to show you what it's doing. So Azure websites.net. So it says called convert. Result pounds ounces. So what this is doing is it's actually doing a kilograms conversion, and it's doing that through a SOAP call. And we'll see what that looks like when you use Edge. So Edge is just a module. You can put it in your package.json. It only works today on Windows. Well, they're in the process of making it so it will work with Mono as well, or I think they may have added Mono support recently. But let's see what this is doing. So here, you can see that I've required the Edge module. And I'm calling this function called func, and I'm passing it service.csx. So service.csx is basically, the reason it's using CSX, it's close to the Roslyn format. If you're familiar with Roslyn, Roslyn is compiler as a service. This is not using Roslyn yet, but it uses some of the conventions. So that's why he calls it CSX. And so once I call this, it's going to give me back a function in Node that can actually call to .NET. And we'll see what it's doing under the hood. And then I'm creating a web server here, standard HTTP web server using Node. And I'm calling that convert kilograms function, and I'm passing it 123. And when it's done, it's going to give me a result. Or if an exception occurs within .NET, it won't throw that from the .NET side. It will actually propagate it over as an error. So let's see what that looks like, the syntax of actually using Edge. So these comments are actually not just comments. These comments are bringing some of the Roslyn syntax of specifying references to DLLs that this is going to use. So you can't, if you delete these, it will not work. This is like a convention that Edge understands. So Edge is looking for a startup class, and it's looking for an invoke method. So that invoke method has a special signature. It can accept a value, and it returns a task of object. So what this is then doing is just writing standard C# code to instantiate the ConvertWait's SOAP client. And what he did was he went into Visual Studio and took the generated code and just copied it in. So this is actually my proxy for talking to my SOAP service, all defined within the script. And then basically what will happen is Edge will just call this invocation. It will call the service. It is designed to be completely in line with what Node expects, so it doesn't block the thread. That's why it uses async. It will not block the calling thread, which will kill your Node applications. So you don't have to worry if you use it. I'm not recommending you use it just to use it. I'm more showing you that this is a capability that is available, and it works in Windows Azure websites. You saw that I just deployed to it. You won't be able to do that on Node.jitsu, by the way. Not that the core Node guys will care, but the .NET guys are usually pretty happy with it. So it's really, really powerful, and all you've got to do is npm install Edge, and you can get it. And I think it's amazing stuff, and a lot of the people in the Node community have been very impressed with Edge because of the fact that it's not a hack. It's really working well with V8. Also, you can call DLLs directly. You don't have to have a script file at all. So it will do either.
Does it run the same process?
It does, because .NET is able to actually be loaded up into the same process. You can't do the reverse yet with Node. You can't actually, from .NET, actually host Node in the same process. We've done lots of profiling. The marshalling is really minimal. It's like exponentially less than if you were doing conventionally what people will do, which is like spin up a web API or a TCP server and talk to it. It's exponentially less. It has much less overhead because it is all in process. So anyway, if you want to get started with doing Lightning Node development, you can go to this URL here. We have a really great dev center with tons of walkthroughs and things like that on how to deploy Node to Windows Azure. You can get the command line tools by doing npm install azure-cli-g. I wanted to point out that my friend Ian is doing a talk on what's the deal with Node.js, where he'll go really into Node.js itself, much deeper than I've gone. I have a talk tomorrow. Azure Mobile Services, some of you may not know, is actually a backend as a service, a new service that we deliver in Windows Azure, which actually runs in Node.js. And you can actually use npm modules from within that. And that is what my talk is about. Like for things talking to Redis, you could even use Edge within Azure Mobile Services. That talk is later today, I think at like 1:45 or 1:50. I'll be at the Microsoft booth, or you can ping me on Twitter @gblock. Thank you guys very, very much for coming.